Hi, I'm Paul Dansbach, and welcome to Fire Engineering's Training Minutes. Today we're going to look at some of the hazards that firefighters may face while operating at a fire in a wood frame building under construction. The original construction of this building is posted beam wood frame. We're going to point out some of the features of the original construction and some of the features created by the renovation that could pose some hazards to firefighters. Our original exterior wall is wood stud. It is post and beam. Up at the top we have our beam that runs horizontally into the corner post. What we see at the bottom in between the stud bays is the code required fire stopping. The fire stopping here is 2x4 blocking. Without that 2x4 blocking, any fire in the basement would extend up into this stud wall cavity. The diagonal bracing in the wood frame system will act as a fire stop, but the diagonal bracing is not located throughout the building. Diagonal bracing is typically found at the corners, an inside corner or an outside corner of the building. As we look up top, we can see our original floor joists run at right angle to this exterior wall. That indicates that this exterior wall supports the floor above. We also notice as we look up at the ceiling, a new 2x4 ceiling has been installed below the original floor joist. The installation of that 2x4 ceiling system has created an additional combustible void space. Should fire occur in this room and get past the interior finish of drywall, or a fire occur up in that combustible void space, that fire has free run throughout this ceiling area. In the original construction, a plaster ceiling, a wood lath and plaster ceiling was installed on the underside of the floor joists. That provided an opportunity, if fire got in between those floor joists, to run in that 14.5-inch space side to side in the building. So the fire spread potential of this building has changed drastically by the installation of that lowered 2x4 ceiling, creating that additional combustible void space. This is another part of the building. This is an interior wall that has been framed out to form a double stud wall with a combustible void space in which they ran building utility, hot cold water line, and a drain waste and vent line. And what this wall creates is, again, another combustible void space for fire to extend into this void space, or fire originate in this void space and extend up through the utility runs, up around the plastic drain waste and vent line, which extends up into the floor ceiling assembly, and then eventually up to the floor above to a bathroom on the floor above. As we continue along this wall, we see a masonry element. We see brick that is part of an interior chimney. The opposite side of this chimney is a wood-burning fireplace. The concern with any interior chimney is the reliability of the chimney. Should a mortar joint go bad, the heat from the fireplace could extend into the wood framing and ignite the wood framing. As we move along, we see another combustible void space, and we can see the common brick of that chimney. Again, there's another combustible void space that was used to run some gas line up vertically through the structure. Any fire that extends from the chimney into this void space might ignite the wood framing and extend vertically through the building. Continuing our look at the building, we're now going to look at a wall that was an original wall to the structure, and it's a double stud wall. Same concept, same fire problem, same concern, that if the fire gets into this combustible wall space, it's got a combustible void space to grow in intensity. The fire will extend vertically through that space. We do have a little bit of a fire stop, but when our interior finish is on the face of the studs, there will be a gap. The fire can extend vertically, hit the underside of the floor decking above, and then travel horizontally through that combustible void space to other parts of the structure. Any part of that combustible void space that's created by the floor ceiling assembly that interconnects with another vertical void space will extend the fire vertically through the building. Combustible void spaces, especially in older structures and structures that are renovated, create some significant challenges to firefighters. Firefighters need to learn about combustible void spaces, learn to anticipate where combustible void spaces will be located in the structure, and aggressively open up the walls, remove the drywall, remove the interior finish to check for fire extension. We can only extinguish the fire after we confine the fire. Another feature that I want to point out at this point is the underside of the existing stairway. There is somewhat of a combustible void space created by the interior finish that conceals the underside of the stairway. Should fire extend into this combustible void space, it will run vertically along the underside of the stairway. What we see in our stairway, we see a 1-inch board that creates the tread for the stairway and a 3/4-inch vertical riser. We have to understand that the stairs are not constructed with the same amount of material as our floor joists are. So the stairway is likely to burn through before the floor joist and the floor decking will burn through. Again, that stairway, fire in the stairway, we need to consider how we're getting up and down from the floor above. We're up on the 3rd floor of the building. The roof above us has been replaced. The roof has been replaced using dimensional lumber. Through that construction, they've used joist hangers to support the ceiling rafters. The joist hanger is a steel hanger that is nailed to a beam or a girder and supports the ceiling joist. The connection uses dissimilar materials. It uses steel connecting to the wood. The steel will soften and weaken in a fire, and the joist hanger gets its bearing surface, or the joist gets its bearing surface from the hanger, which is supported by the nails. We're going to walk over and look at a more traditional framing method that provides a different means of support for the ceiling joists. Up here we have a very traditional method of framing, and that framing is where the ceiling joists overlap the bearing wall. Here is our bearing wall, and the bearing surface for the ceiling joist is achieved from the top plate of the 2x4 bearing wall. This is a much better, more secure, more collapse-resistant connection than the connections constructed using joist hangers. Today we pointed out some of the features of a posted beam wood frame building. All firefighters should be encouraged to visit buildings under construction within their fire department response area to understand local construction features and concerns. Thank you for viewing this video segment.